This video is about the symmetry of the unit circle. If we understand its symmetry, it's a lot easier to make use of this entire unit circle. So we'll have a blank unit circle here in front of us on the x and y axes, of course. This time, though, you'll notice some extra little line segments I've painted on top of this circle. So these line segments mark off our special places. I'm going to go through and put some points where they are. So if I start over here on the right side at the point 1, 0, as we've been starting for all of our arcs, and then start to rotate counterclockwise to the spot where I would hit the pi/6 terminal point for that special arc, or the 1/6 special fraction. I'm going to put a point where that would be, and then not too far past it would be the place for the pi/4 special arc or special fraction. I'll put a dot there also, and then not too far after that would be the pi/3 location. I'm just going to put dots at all of these places for now. If we kept rotating to the top of the circle, we'd hit the point, of course, 0, 1. And then if we continue into quadrant 2, the next place we'll come to is the 2 pi/3, or the 2/3 special fractions mark, then the 3/4 right in the middle of that quadrant 2 arc, and then on to the 5/6 or 5 pi/6 special arc place. And then if we kept going one more spot, we'd be at the left side of the circle where the point -1, 0 would be. So far we know those places from our understanding of this unit circle. I just want to reference them with dots at this point. Let's continue and put dots at all the other places in the bottom half of this unit circle. Continuing to rotate counterclockwise now, but in quadrant 3, the first special place we come to would be 7/6, or 7 pi/6, and then 5/4, or 5 pi/4, and in the middle, 4/3 special fraction, or 4 pi/3. And then if I kept going down to the very bottom, that's of course where 3/2, or 3 pi/2 would be. And let me finish out these last 3 special places. This next one over here would be 5/3, and then 7/4, and then 11/6, and all the way back up to the point 1, 0, where you would hit 2, a full rotation. All right, so I know there's a lot there, but hopefully those special fractions and special arc lengths are sinking in so that these places at least look familiar. Now, I'm not going to put any more numbers on this picture yet. What I want to talk about right now is the symmetry of this circle. The symmetry is going to be our friend. In fact, if we understand the symmetry, there's a lot less to memorize with this circle. Okay, by symmetry I mean this. If I find, let's say, this first point in quadrant 1, which would be the pi/6 special arc place that stops, I'm going to give that point coordinates x, y. Now remember, those have actual numbers that we're not getting to yet, but just for a moment, let me label that as x, y. If we just understand the coordinate plane we're working on, that means the x-coordinate of that point is x. Now, let me go back down to the x-axis and just put a little tick mark where that would be. So that means this distance here is x, from the origin to where that location is. Now, if I kept extending from that point x, y, I labeled at the pi/6 terminal point, if I kept that, if I extended a line vertically straight down, by symmetry, it should hit this point, which would be the 11/6 pi, or 11 pi/6 location in quadrant 4. In other words, both of those points, if I connect them with a vertical line, hopefully it's obvious, are at the same horizontal location. In other words, they're both x units away from the origin to the right. Now, let's continue this idea. If I head over to, let's say, the point here in quadrant 1 in the middle, which would be the pi/4 special arc terminal point location, or the 1/4 special fraction, the same thing would happen there. If I extended a vertical line straight down from that point, it would eventually hit its corresponding or symmetric point in quadrant 4, which would happen to be the 7 pi over 4 special arc terminal point location. So again, the symmetry of the circle tells us that those 2 points must have the same x value for their coordinates. Now, hopefully you're getting the idea. There are a whole bunch of pairs of similar or symmetric points. I'm going to connect them. This is going to start to look a little messy, but I'm going to connect all of the special arc terminal points in the top half of our unit circle with vertical lines to their symmetric or corresponding points in the bottom half. Again, this symmetry will really help us memorize and understand how this unit circle works. All of these pairs which I'm connecting are right above each other, one in the north half of this circle, one in the bottom half, and they all, in pairs, have the same x values. Let's do the same idea with symmetry of all the y values. So now, let's start back with the pi over 6 special arc terminal point in quadrant 1. If I were to extend horizontally now, directly over, I should eventually hit a symmetric point in quadrant 2. Now, that point in quadrant 2, which is symmetric, would be the 5 pi over 6 terminal point. And this same symmetry can be applied horizontally with all of these points. So I'll go to the pi over 4 special terminal point, extend that one straight over, and it should hit the, can you guess, 3 pi over 4 terminal point location. And then I'll go up to the pi over 3 point, extend that straight over, and that would hit the 2 pi over 3 terminal point location. Okay, so now let's go to the bottom half, quadrants 3 and 4, and apply the same horizontal lines indicating the symmetry of these points. These 3 points in quadrant 3, which I've now connected with these 3 points in quadrant 4, all share those corresponding values. So these 2 points, this one being 7 pi over 6 and this one being 11 pi over 6, for example, they would have to both have the same y value, which would be whatever the y value is here. Again, we don't know that number yet, we'll get to it. Or, similarly, for example, this special arc terminal place, which would be the 4/3, or 4 pi over 3, would have to have the same y value, y coordinate, as this terminal point, which of course would be 5 pi over 3. Alright, so hopefully we're getting the idea of the symmetry behind this. The only thing we have to do next is put some actual numbers in these coordinates to start making more sense of this. Now, try not to be alarmed by the clutter on this picture. Okay, I will explain. But this is everything. So, everything we've discussed about the unit circle, you can see on this picture. And I've tried to add some clarity to it with some things. I hope it helped. We'll see. First of all, let's point out the obvious. If you look within this, I guess, secondary circle inside, you will find our familiar measures. So there is 0 and 2 pi, our starting and ending arc lengths. And then you'll notice in order we have them. Now, they're kind of staggered in different locations just so that they can all fit on here, but we have pi over 6, pi over 4, pi over 3, pi over 2. So those are all of our special arc lengths plotted on this circle, as we've seen already. Now, you'll also notice a lot of extra stuff on the outside. So there are these now coordinates next to each point. Of course, we already knew the 1, 0 and the 0, 1, but now you have some others here in the middle that just kind of look maybe not so pleasant, but we'll see. They're not terrible. There is a lot of symmetry. In fact, this point would be symmetric vertically down with this point and horizontally over with this point. The beauty of that is that really all you have to understand are the values in this first quadrant for all these coordinates, and if you know them and you know the symmetry, you automatically know all the other values. For instance, the x value of this point here for pi over 6 is root 3 over 2. Well, guess what? Symmetrically, this point down here at 11 pi over 6 has the same x value. Similarly now, the y value of this point at pi over 6, it's 1/2, should be the same, and it is, as the y value of the symmetric point way over here at 5 pi over 6. Notice that's 1/2. So the symmetry will help fill in all the values we need to know. Now let's understand a trick to knowing the values in quadrant 1, and if we do, the rest should all fall together. Here's the trick. Now this is just a little memorizational visual trick, but it works, it's helpful. I want you to, instead of seeing these numbers that are in these coordinates, imagine this. Instead of 1, we're going to call that for a second the square root of 4 over 2. Now that seems a little ridiculous because that reduces to 1. Square root of 4 is 2, 2 over 2 is 1, yes. Okay, but bear with me here. If that's the square root of 4 over 2, now work back up to the next point you see here. Notice that's square root of 3 over 2 in the x location. Okay, now work back up to the next point. Again, we're just looking at the x coordinates for now. That's square root of 2 over 2. And then the third point up here at pi over 3, I'm going to rewrite that one. Instead of its x coordinate being 1/2, as you see here printed, let's call that square root of 1 over 2. Again, that seems a little ridiculous. The square root of 1 is 1. But now watch how nice this is. The x coordinates, starting here at the point 1, 0, in order, rotating counterclockwise up through the point 0, 1, are as follows. Square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and you could even call this the square root of 0 over 2, just to make the pattern fit. So that's how nice it is. Now, look at the y values of all these points. It's exactly the opposite. So again, over here at the point 1, 0, that y value is 0, or you could say square root of 0 over 2. Next would be square root of 1 over 2. I know that's 1, but that follows the pattern. Square root of 2 over 2, square root of 3 over 2, and then lastly you could call this top at the y value at the top of 1. So this little pattern, this visual pattern, will help us continue and fill in any value you want as long as you know the symmetry. For instance, let's say you wanted to find the coordinates of this point over here where we have 4 pi over 3. Okay, so this is now quadrant 3, and it's our third point of special arcs in that quadrant, rotating counterclockwise. If you know the symmetry of it, you can hopefully quickly trace this point vertically, back up with this point, and then back over with this point, and this will give you a couple things. Number one, the x value will be the same as it would be vertically for these points. In other words, this x distance is the same as this x distance. And if you know the quadrant 1 point, you'll know that that's 1/2. So guess what? This would be negative 1/2. And sure enough, that's exactly what the x value is there. Okay, now for y values, you know that this would be symmetric. This point down here at 4 pi over 3 would be symmetric all the way up with this point, which you could translate over with this point. Okay, so the vertical value of this third point at pi over 3 in quadrant 1, we know it's, I can hardly tell now, but it's square root of 3 over 2. So that vertical value would be the same as this, and there it is, square root of 3 over 2. Now, symmetrically, it should be the opposite then of this value, and sure enough, that would be negative square root of 3 over 2. So the symmetry of the unit circle, along with hopefully just understanding at least the first quadrant, will help anyone figure out what any coordinates of any of our special arc terminal points are.